So far I've been being very nice to you with respect to circles, in that I've only given you equations like this one here on the right that are written very nicely for you, so you can figure out the center and the radius, right? However, a lot of them in the wild show up a little bit messier looking. So in the past, we've employed a strategy, particularly with linear equations, right, of rewriting them in a way that's a little bit more nice for us to figure out what we need to know. And here's an example of that, right? So rewriting in our y equals mx plus b, we call this slope-intercept form, which allowed us to figure out the slope and the y-intercept of the graph. So that's what we're doing here. We're going to take our messy circle and we're going to turn it into something useful. And in fact, these two equations represent the same circle, and you could double check that if you don't believe me by graphing them both on Desmo, so you get the same thing. So we're going to use a strategy here called completing the square. And completing the square relies on knowing a certain factoring pattern, which you know, but I'll remind you of right now. So an example of this factoring pattern is that if I have x minus 6 squared, well, that's the same as x minus 6 times x minus 6, because that's what squared means. This is why it's called completing the squared, by the way, which is the same as x squared minus 12x plus 36. So notice what I end up with is twice the number here and the square of the number here, right? So this is 2 times 6, and then this is 6 squared. So that allows me, if I know that, to rewrite my equation here. So I can turn this into a perfect square in order to solve it. And this is just a baby example. We'll go back to our circles examples here in a second. Do something a little easier before we tackle the big guy. So what I can do is I can turn this into x squared minus 12x. And then leave myself a little space here and equal to 28. And then I'm going to add in that 36 that I need to complete the square. But it's an equation, so if I do that on the left, I have to do that on the right as well. Right? So here now, what I get is my perfect square on my left. I just add my terms on the right, so I get 64 on the right. And then I can rewrite that as x minus 6 squared. And then I can square root both sides. That's why it's useful to me here. Is I can be like, okay, just plain old x minus 6 is equal to positive or negative 8. And then I could solve it from there, right? If I wanted to get my x's for my quadratic. And that's completing the square. Now, we need a rule, right? We need to figure out which number to add. So I picked 36 because I already did this example. But if I run into one in the wild, well, how do I figure that out? Well, the rule is find your b term, divide it by 2, then add the square of that number. Right? So here is my b term, 12x, and b over 2, well, is negative 6, and then b over 2 squared is negative 6 squared, and that's my 36 that I'm adding in. Okay, so that's how I find that number. And notice this example that we did looks awful like our circle equations here. Right, so that's completing the square. All it is a way to rewrite things. Now, notice we have two variables in my circle equation, so we're going to have to do it twice. So let's jump into that. I'm going to start by just rewriting it. But I'm going to rewrite it in a particular way. So I'm going to put my x's next to each other and then put my y's next to each other. Make sure I get my signs right here. And then I'm going to go ahead and move that 28 over to the right-hand side. So I'm adding 28 on both sides. And as I rewrite it this time, I'm going to leave myself a little bit of space. So I'm going to leave my space next to my x's. And then again next to my y's. Because now is the part where I need to complete my squares. And I'll just make this note that b over 2 here is negative 6 for my x terms. Ooh, and it's also the same for my y's. This one will always be true. It makes our life easier for this example. So I'm going to add in b over 2 squared. So in this case, 36 here, and whatever I do on the right, I do on the left, and vice versa. And let's switch colors here. My y's also get a plus 36. And notice this is always positive because it's a square, right? It doesn't matter the signs. And again, I have to do that same thing to the right-hand side. So now I've completed my square. On the right-hand side, this ends up, oh, well, we know what we're going to get, by the way, because we know it's going to be 100 on the right-hand side, but those do add up to 100. And now I have 2 perfect squares on the left. Let's give myself a little bit more room here. So I have x squared minus 12x plus 36 is my first perfect square, and then my second perfect square is my y squared minus 12y plus 36. And then I can factor those out to my perfect squares, right? So I get x minus 6 squared is my first term plus y minus 6 squared is my second term, all equal to my 100. So if I wanted to find my center and my radius, well, there we go. And this was not super meaningful because I gave you this already. But that's, of course, how I would tackle that if I hadn't given you this solution. But my center is, of course, 6 comma 6, and we know this from the previous lesson. And my radius is the square root of 100, which is 10. So that is completing the square. So we've just discovered the y equals mx plus b of our circle equations.